Hello dear students, welcome back to Vastcoaching. Today we are going to discuss about trigonometric functions. You have already studied about trigonometric ratios, identities and some of the applications, how the trigonometric ratios can be used to solve the problems like height and distances. Right? Today in this class we are going to discuss about the trigonometric ratios. We are going to generalize to trigonometric functions and study their properties. So let's get started. First of all, what's an angle? Angle is nothing but it's a measure of rotation from initial side to terminal, right? If I draw an angle, this is my angle theta. Angle is nothing but it's a measure of rotation from initial side to the terminal side, right? If we take the rotation in the anti-clockwise direction, we call the angle as positive angle, right? Such angle is called as positive angle. If the rotation is in clockwise direction, that we call it as negative angle. Suppose if I take this angle, if we take the angle in the clockwise direction, that we call it as negative angle. So this is the difference between positive and negative angle. There are many types of measurements we have. We are going to discuss mainly three types of measurements. The number one is hexadecimal system. In this system, the unit of the measurement is degree. So unit of the measurement is degree. Sometimes we call it as degree measure as well. In this, one right angle is nothing but 90 degrees. And each degree is divided into 60 parts. That we call it as, each part we call it as 1 minute. So 1 degree is nothing but 60 minutes. And each minute again it's divided into 60 parts. That we call it as 60 seconds. So this is how we write in the hexadecimal system. So everything is in terms of 60, right? So one right angle is 90 degree, 1 degree is 60 minutes and 1 minute is 60 seconds. So unit of the measurement is degree. The second method is centesimal system. In centesimal system, the unit of the measurement is gradian. In this you can see that cent, everything we are talking in terms of 100 units. So here one right angle is nothing but 100 gradian and 1 gradian is nothing but 100 minutes and 1 minute is nothing but 100 seconds. So in this system everything we are talking in terms of hundreds, so that's why the name is centesimal system. And the last system is circular system. Circular system, in this the unit of the measurement is radian and sometimes we call it as radian measure. The unit of the measurement is radian and we know that if I take a unit circle, what's the circumference of the circle? That's 2 pi r. When I take the unit circle, circumference will be 2 pi. So we know that 2 pi, that's nothing but one complete rotation is 360 degrees. So 2 pi radian, we have 360 degrees and pi radian is 180 degrees, or simply I can write pi by 2 radian is nothing but 90 degrees, right? So what's the relation to connect between these three systems. So there is a relation which we can connect between these three systems. The relation is T divided by 90, which is equal to G gradient. D is degree, G is gradient divided by 100, which is equal to circular system. Let me denote by C, pi by 2. So this connects between these three relations. So this is the relation by using which if any one of the quantity is unknown, we can find in terms of other. So usually we use the degree and radian measure. So how we can find the relation between degree and radian measure? Let's see now. Relation between degree and radian measure. Just now we have seen that pi radian is nothing but 180 degrees. So from this, can I write 1 radian is nothing but 180 by pi? Right? So from this, again can I write 1 degree is nothing but pi by 180? So this is the relation we are going to use when we convert from degree to radian or radian to degree measure. So let me take one small example. Convert 5 pi by 3 radian to degree. We need, this is a radian, so we need in terms of degree. So what we are going to do is the radian measure you will write multiplied by, we need in terms of degree, so you will multiply by 180 degrees divided by pi. So that we will get, so this is 1 sum 6, so this is nothing but 5 to 60, we have 300 degrees. So we can write 5 pi by 3 radian is nothing but 300 degrees. So this is how, using this relation, we can convert the given radian to degree. So vice versa. Even if the degree is given, you just have to multiply by pi and divide by 180 degrees so that you get the corresponding radian measure. So now let us take a unit circle. And you can see that the coordinate points over here, that is 1, 0, 0, 1 and minus 1, 0 and 0, minus 1. We have these corner points, right? Let us take a point P whose coordinate points are A, B and it is forming an angle theta. We have studied trigonometric ratios for an acute angle. Let us extend this definition for any angle within this circle. And in terms of pi, radian, let us talk. See, let us define few things. Let A is equal to cos theta and B is equal to sin theta. From this figure, we can make out that this is cos theta followed by sin theta. Cos, here theta is forming 0 degree, right? So we have cos 0 is 1, sin 0 is 0, right? When I take this point, cos, it reaches to this quadrant, so cos is, theta is pi by 2 over here, cos pi by 2, that is 0, and sin pi by 2, it's 1. When we take the angle over here, so theta will be equal to pi. So we have cos pi is minus 1 and sin pi is 0. So similarly, when I come to this point, the angle which is making is 3 pi by 2 or 270 degrees. So cos 3 pi by 2 is nothing but 0 and sin 3 pi by 2, which is minus 1. Dear students, can we conclude something out of here? Look at these values. cos 0 is 1, cos pi is minus 1, cos pi by 2 is 0, cos 3 pi by 2 is 0, sin 0 is 0, sin pi is 0. Can we make out something from this? Sin is taking the value. Can we conclude this? Sin x is 0 whenever x is multiple of pi. When sin n is 0, sin 0 is 0, sin pi whenever n is 1, sin pi is 0, sin 2 pi is 0, sin 3 pi is 0, etc. So we can conclude that sin x is equal to 0 when x is n pi and this n is nothing but some integer. Similarly, can we make out one more thing? When and all cos is 0, cos of an angle x is 0, when and all x is a multiple of pi by 2, 3 pi by 2, next 5 pi by 2, 7 pi by 2. You can see that cos odd multiples of pi by 2 is 0. So can we just write odd number we denote by 2n plus 1, pi by 2. n is belongs to some integer. So sin x is 0 when and all x is a multiple of n pi, and cos is 0 when and all x is multiple of pi by 2. So from this figure we can conclude this, right? Now let us see the trigonometric ratios in which respective quadrant they are positive. So usually we take an angle in the positive x-axis, right, or anti-clockwise direction. So this is our first quadrant, and this is second, and this is third quadrant, and this is our fourth quadrant, right? In the first quadrant, all the trigonometric ratios are positive. So we can just write all the trigonometric ratios are positive. Let me just write A. In the second quadrant, sine and its reciprocal cosecant is positive. In the third quadrant, tan and its reciprocal cot is positive, and rest all the angles are negative. Similarly, in the second quadrant, and in the fourth quadrant, cos and its reciprocal secant is positive in the fourth quadrant. So we can remember this sign conversion, or in which quadrant the respective trigonometric ratio is positive. So you can just remember by this sentence. There are many tricks. This is the one of the way you can remember. All students take coffee. These first letters I have marked. All students take coffee. All students take coffee. So by this way you can remember in which respective quadrant which trigonometric ratios are positive. Alright. Okay. The next is about allied angles. Allied angles are nothing but when and all the two angles whose sum or the difference is either 0 or multiple of pi by 2. Such angles are said to be allied angles. It can be plus or minus theta, or it can be pi by 2 plus or minus theta, or it can be 3 pi by 2 plus or minus theta, or I can say pi plus or minus theta, or 2 pi plus or minus theta, and so on. These are the allied angles. Now let us take some examples and let us see how we can find the value of the given trigonometric ratio. Now, how to calculate the values of these trigonometric ratios? There are two steps. First, we need to check which quadrant these ratios belongs to, and the second is it a multiple of pi? We need to check. Look at this, pi plus theta. Pi is 180 degrees plus theta. It falls in third quadrant, and sine is negative. So you will put the sine. Sine is negative in the third quadrant, and whenever it's a multiple of pi, there will be no conversion. So this is a supplementary of an angle. What is a supplementary of an angle? Whenever the two angles whose sum is 180 degrees or pi, right? So either it can be theta or pi minus theta, right? So such angles are called as supplementary angles. You can see here pi plus theta comes in the third quadrant, it falls in the third quadrant, and sine is negative in the third quadrant. Sine, whenever there is a multiple of pi, it remains as it is, sine theta. There will be no conversion. Cos 2 pi minus theta, 2 pi minus theta, it lies in the fourth quadrant and cos is positive, so you will place the sign. Cos 2 pi minus theta, so we place the sign. Whenever it's multiple of pi, there will be no change, so it will be cos theta. Tan pi minus theta falls in second quadrant. Tan is negative in the second quadrant because only sine and cosecants are positive. So tan is negative. So this will be just tan theta. What about the cot 5 pi minus theta? 5 pi. This is 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. 5 pi minus theta. It falls in second quadrant. Cot is negative. So you just write cot minus cot theta. So what about the last one? Again secant 5 into 180 degrees minus theta. It falls in second quadrant and secant is negative. So we can just write minus secant theta. So whenever there is a multiple of pi, there will be no change. Only you need to check the respective quadrant. So this is how we can write the respective trigonometric values. Whenever we have these type of trigonometric ratios, whenever it's a multiple of pi by 2, I mean whenever it's a multiple of odd multiples of pi by 2, in this case what happens is sine changes to cos and cos changes to sine. It's just we are taking a complementary angles because it's in terms of pi by 2, right? What are complementary angles? When two angle sum is pi by 2. If one angle is theta, the other angle will be pi by 2 minus theta, right? So it just takes its complementary angle. So sine, its complementary is cos, and tan, its complementary angle is cot theta, and cot, its tan, and secant, its complementary angle is cosecant theta, and cosecant, its complementary is secant theta, right? So let's start how to write the values of these trigonometric ratios. So cos pi by 2 plus theta. First of all, the step number 1 is you check the quadrant. Pi by 2 plus theta, pi by 2, that's in first quadrant, plus theta, it falls in second quadrant. Cos is negative in the first quadrant, cos is negative in the second quadrant, and cos, it's an odd multiple of pi by 2, 1 into pi by 2, right? So it's an odd multiple of pi by 2, so cos changes to sine theta. Alright, so step number 1 is you will check the quadrant, and second step you will write its complementary whenever it's an odd multiple of pi by 2, and the third one you will attach the respective angle. So 3 pi by 2 minus theta, 3 pi by 2, it is in the third quadrant, minus theta, so it falls in the third quadrant. 3 pi by 2 is 3 here, 3 pi by 2 minus theta falls in third quadrant. So third quadrant, sine is negative, and since it's multiple of odd multiple of pi by 2, so sine changes to cos theta, right? So this I hope you can do it. Secant 3 pi by 2, so it's an odd multiple of pi by 2. Before that you check the quadrant. 3 pi by 2 plus theta, 3 pi by 2 plus theta, it falls in the fourth quadrant. Secant is positive, and secant, its complementary is cosecant theta. Next one, tan 7 pi by 2 plus theta, 7 pi by 2 plus theta. So this is pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2 plus theta. It falls in fourth quadrant. So tan is negative, so we can simply write minus cot theta. What about the last one? 5 pi by 2, pi by 2, 3 pi by 2, 5 pi by 2 minus theta. So it falls in first quadrant. All the trigonometry ratios are positive. Cosec, it's a multiple of odd multiple of pi by 2. So cosecant will change to secant theta. So this is how you can write the respective these angles in terms of the trigonometry ratios. Whenever it's an odd multiple of pi by 2, we can write their respective allied angles like this. If you have any doubts or queries, you can mention in the comment box. And to know more about us, you can visit our website www.vastcoaching.in. Thank you. Have a good day.